the last thing we're going to finish up is the second part of 4.1. And what we're going to be looking at in this part is basically solving a triangle. Okay, so what does it mean to solve a triangle? It means to figure out everything that you don't know. Triangles have 6 different things we have to find. 3 angles and 3 sides. Now, one thing we already know is we're working with right triangles. So that means we already know that one angle in every triangle is
90 degrees.
90 degrees. Okay, so that's one thing we don't have to find. In order to be able to find the information that is missing, I have to give you something to start with. Right? There are 2 different types of situations I could give you. Right, so I could give you either a side and an angle. Okay, this is in addition to the 90. Everything has a 90, so you know the 90 all the time. But in addition to that, I could give you either one of the other sides and one of the other angles, and then from there you solve for everything. Or I could just give you both of the sides. Depending on which case you have, it's a little bit different on how you solve it. So we'll go through a couple of each type. So we're going to keep in mind a few things about triangles. What's the theorem we've been using that relates to the sides of a triangle?
Pythagorean.
Yep, so we can use the Pythagorean theorem. That's definitely something that'll come up. And what do we know about all the angles in a triangle?
They all add 180.
They all add up to 180, yeah. They total. Yeah. So what we're going to do is first, when we're given information, we're going to draw it. Okay, the reason we're going to draw it is because we have to figure out what's opposite and what's adjacent. Okay, after you've done enough of them, you can kind of do it in your head, visualizing it. But I think at first, it's kind of helpful to make a sketch. And then, after we sketch it, we're going to make a table. So the table is going to have 6 things in it. A, B, and C for the sides, and then Greek letters for the angles. What do we call the angle that's across from side A? In terms of a Greek letter. What is it?
Beta.
Well, beta is going to be the one across from B, so that's important, but that's beta. Alpha is the one across from A. I never gave you a name for the one across from C, because that's the right angle. Since it's always 90, we don't need a name for it. We can just call it the right angle. When it's not 90, that'll be in a couple weeks, we'll use a name for it. For this week, we'll just call it the right angle. All right. So let's see if we can solve this one. Okay, it says solve the triangle. B is 2, alpha is 40. Okay, which case is that?
What is it again?
What does it say? B is 2 and alpha is 40.
So we know a side and an angle
We know a side
and an acute
and we
angle.
know an angle. Yep. Now you should have one. Thanks. Yeah, so we go a side and an angle. It's going to be this first case. Okay. What's the first thing that I said to do once you have your information? Draw it out. Yep. So first thing is make a sketch. Then we'll do a table after. How you physically draw the triangle, like which way it's facing, that doesn't matter. As long as you put A across from alpha, B across from beta, and C as the hypotenuse. Okay? I might switch A and B at some point, and that's fine to do, as long as I also switch alpha and beta with it. But just keep A across from alpha and B across from beta. All right, so B we know is 2, so label that side 2, and alpha we know is 40 degrees. Okay. These are the 2 pieces of information that are given. Okay. Question on the diagram.
We can find the other acute angle.
Yep, so now we're going to make a table and we're going to start writing down things we can figure out. So I wrote down the 3 sides on the left, the 3 angles on the right, and what we have is case 1. Okay, that's the case where you know a side and an angle. And we can find the other angle right away. How much is beta?
4. Oh, beta, so 90.
It's 50 degrees.
50, yeah. Okay, now that we know beta is 50, we're done with all the angles. So now we just have to finish the sides. Which, out of the 3 things we needed to find, you can do any of them in any order. Right? I usually do the angle first, but you don't have to. Okay? You can find any one of these boxes first, any one of them second, and then whatever one's left over is the third one. So, we could pick next. Do we want to do A or C?
A.
A. Okay, so we're going to find A. So what I want to do is go back up to my diagram. I've already circled the 2 pieces of information that were given. I definitely need to use both of those. And because we chose to find A, I'm going to circle that too. Okay. Next thing I need to do is label the positions of each side. Not the name, the position, where it is. Where is the side that's A in relation to 40? So it's the opposite. How about the side that's 2?
Adjacent.
Adjacent. And the C? That's the hypotenuse.
Wait, why would we do it from 40? Like, what if we did it from like the beta from 50?
We're going to talk about that right now.
Okay.
So my next question is, why do you think I chose the 40 and not the 50?
It's opposite to A.
Because what?
It was given.
It was given. Why is it good to do something that was given?
Because you know it's right.
We know it's right. Yeah, we know it's right. It's not that you can't use the 50, but if you use the 50 and you made a mistake, then everything you use the 50 for is wrong. So when we are solving one of these problems, we never want to use something that we found to figure out something else. Always go back to what was given, always. That way, if you make a mistake, hopefully your mistake is just on one thing and not everything. Okay, so now we're going to find A. What is the name of the side, or what's the position of the side we're trying to find?
Opposite.
We're trying to find opposite. What's the position of the side that we already know?
Adjacent.
Adjacent. So now, we want to know the opposite. We know the adjacent. Every problem we do today, we're going to either choose sine, cosine, or tangent to solve. Every problem. We're not using secant, cosecant, and cotangent. Maybe we don't have buttons for them on the calculator. The way that you figure out which one to pick is you look at the names of the sides, opposite and adjacent. Which trig function has those 2 in it?
Cosine.
So, tangent.
It's one of those 3.
It's tangent.
It's the tangent, yes. So what we're going to do now is set up an equation, and we're going to use tangent. The reason it's tangent is because you're not using hypotenuse. Tangent's the only one without hypotenuse. Tangent is opposite and adjacent. So you write down, you're going to have a trig function, what you're plugging into the trig function, and then a fraction on the other side. So our trig function is tangent. What we fill in here is the angle.
So would it be 40?
In this case, we're doing everything with the angle that was given, the 40. Yep. So tangent of 40 equals, and now opposite over adjacent.
So A over 2.
A over 2. Yep. A over 2. And now we solve for A. Okay. Only thing we have to do to solve for A is get rid of the dividing by 2.
So we times both sides by 2?
Times both sides by 2. Times 2. Times 2. And that is what we need to plug in. 2 tangent 40. That's A. Let's type it in. If I type it in right now, it's not going to come out right. What do I need to?
Degrees.
I need to make sure I'm in degrees. Every problem in this lesson is degrees. I'm not saying every problem on the test, but every problem from this lesson is in degrees. Okay, so put it in degrees. And now type 2 tan 40. So A is, we're going to go 3 decimals, 1.678. That's it. That's how you find A. Any questions how I got A?
Wait, can you just go back down for a second? I thought you had it multiplied both.
Yeah, we multiplied both sides by 2.
No, I meant like the top and the bottom.
Oh, no.
But I get
Wait,
it now.
so after I know that I'm doing tan, then it's just tan 40 equals the opposite over the hypotenuse? Or opposite over adjacent, I meant? Okay.
Okay. Now, a couple things we can check as we're doing it to make sure we're on track. The smallest angle should always be with the smallest side. The biggest angle is going to have to be with the biggest side. And then the angle that's in the middle, that side should be in the middle. Okay? So I know that this is the smallest angle, and 1.6 is definitely smaller than 2. So that's good. The other thing that should always happen in a triangle is any two sides, bless you, any two sides added together should be bigger than the third. So that means when you add A and B together, it has to be bigger than C. So like C couldn't come out to 20. That's way too big. Right? If you had a side that long, your triangle would look like this. The other two sides would be too short to connect. Okay, so any two sides added together have to be bigger than the third. Right? So let's find C, and then we can check that. Okay, we've got two sides. What can we do in a right triangle if we
The
have two
Pythagorean
sides?
theorem.
We could do the Pythagorean theorem, but why do you think I'm going to say that's not a good idea?
Because there's a decimal.
Okay, this is a decimal, which first of all, it means it's
Because
rounded.
we found that number.
And we found that number, so
It's not given.
it's not given, which means
It could be wrong.
it might not, yeah, it may just be wrong. Okay, so we're not going to use this at all to find this. So let's find C. And we're going to find C the same way we did A. Okay, let's circle again what we're going to use. Okay, so this time focus on the ones that are in green. 2 was given, 40 was given, and the C we don't know.
Isn't also 90 given?
Yep, we can't ever use the 90
No.
because that's in every triangle.
Okay.
We have to use the information that's special to this triangle. But yeah, the 90 was given. Okay, so now we know the adjacent.1What's the position we're trying to find?
Hypotenuse.
Hypotenuse.
And that's
Adjacent and hypotenuse. What trig function is that?
cosine.
Cosine. Yep. So trig function, the angle you're going to plug in, fraction on the other side. Okay. What's the angle that we're going to fill into the cosine? Yeah. If they give you an angle, it's always the given angle. It's the 40.
What if they don't give you any angles?
That's going to be the second type. We haven't done that yet.
You don't have to do that.
Well, we don't have to, but you might want to.
It's adjacent over
gonna be a-
hypotenuse.
So yeah, adjacent over hypotenuse.
So
2
2 over H.
Over
2
C.
over C.
Oh.
Okay. And we're going to solve for C using the same step that we did
Would you
originally.
divide them both?
So what operation did we use first in the last problem?
Multiplication.
Multiplication. We're going to do the same thing here. What am I going to multiply both sides by?
C.
C.
C. Times
Wait,
C.
why C, not 2?
Well, if you multiply both sides by 2, you'd still have a fraction here. It would just be a 4 over C. What we're trying to do is get rid of the fraction completely. So we multiply both sides by C. What happens to the c's on the right?
They cancel.
They cancel. Now we just have 2. And then on the left, c times the cosine of 40. Now, how would we get c by itself?
Divide by cosine of 40.
Yeah, when you have a number next to a letter and you want to get the letter alone, you divide. So divide by cosine 40. Divide by cosine 40. That cancels out. And we get c equals 2 divided by cosine 40. Okay, now look at what we have here. Okay, that's our final answer. And look at what we started with. There's a way we can just go from this step right to that step.
Can't you just divide both sides by 2?
If you divide by 2, you'd still be left with a c in the bottom. But does anybody see how you can go from that step right to that step?
Replace the c with cosine.
Right. If you just switch the c and the cosine 40, you automatically get c by itself. So from now on, anytime I have something like this, where I have a number on the left, a number in the top, and a letter in the bottom, just like that, you can just switch these two. And that's how you get the letter by itself. So the answer is 4/3. If you don't want to switch those two, then you can go through these steps each time. It's an extra step. Okay, so that shortcut just saves one step. All right, and now remember, you've got to type that in. I know that it has to be bigger than 2, because it's the hypotenuse, but it can't be bigger than 3.6. Okay, it has, these two sides added together have to be bigger. All right, let's see what we get. 2 divided by cosine 40. I didn't close the parenthesis. It's not a big deal because there's nothing else that was typed in after it. So 2.611. So that's C. And that's how you solve a triangle. So we found everything that they wanted us to find. Now, if you have time and you want to double check your answer, you could use Pythagorean theorem to double check it. If I type in 1.678 and I square it, plus b squared, I get that. When I do c squared, what should it come out to?
That.
It should come out to that. A squared plus b squared should equal c squared. And it's close. It's 6.816, 6.817 if you round. It's because of rounding. Okay, but they're basically the same. So that confirms I did the problem right. Okay, any questions on that one? Okay, so that's a side and an angle. Let's try one more with a side and an angle. Okay, this time I'm giving you the information in the table right away. Okay, you might not need to do this for this step, but you are going to have to do this eventually to make things easier to see. So what is it that we always want to do with that information?
Make a graph or draw it out.
Draw it out. Yeah. So let's draw it out. Let's put A over here, which means what's the name of the angle in the lower right?
Alpha.
Yep, so this is going to be alpha. Let's put B on the bottom.
So it'd be beta.
So beta goes at the top. And C is pretty much the only one you always put in the same spot. That's the hypotenuse. Okay, so now we've got our diagram. We can find any one of the boxes first. So which one do we want to do first?
The alpha.
Alpha. Okay, so let's do alpha. What's alpha going to come out to?
60.
What do these two have to add up to?
70.
They have to add up to 70?
No, they have to add up to 90. The
Oh, okay.
answer is 70.
They have to add up to 90. So the answer is 70. Okay. Any questions on how we got 70? Now, we have a choice when we start solving for the other sides. Are we going to do everything from alpha or from beta?
Beta.
Why beta?
It's given.
Because it was given. Yep. So I'm going to circle the two pieces of information that were given. I'm also going to label my sides. So everything is from the 20. What is the side that's 6 units long? What position?
A.
So A is, that's like a name of a side. I need the position of the side. Adjacent. And what about the position of side B?
Opposite.
Opposite. And the position of side C? Hypotenuse. Yep. Okay. So now our choice, B or C. Which one do we want to do next?
Wait, so
B.
whichever angle is given, that's always the one that's like the theta?
Yeah.
Okay.
Yep. So wait, which side do you want to do? C? Okay. Find C. Okay, so first step, you're finding C. So C is the hypotenuse. And what was the position of the side that we know?
Adjacent.
Adjacent. Now you got to figure out which trig function.
It's cosine.
It's cosine, adjacent and hypotenuse.
And it's 20. The
So-
angle is 20.
Fill in your angle for the cosine function.
And then it'd be adjacent over hypotenuse.
Adjacent
So
over
6
hypotenuse.
over 6 over C.
Yeah, adjacent over hypotenuse, 6 over C. Okay. Now this is the one we can use the trick that I just showed you. What does C equal?
6 over cosine.
Right, we can just switch the C and the cosine 20. And that's our answer for C. So type that in and see what we get. 6 over cosine 20. Okay, 6.385. Okay, that looks good because that's supposed to be the biggest side. And it is a little bit bigger than the side we had, so that's good. If it came out smaller than 6, something wrong. Yeah. Okay, now B, that's going to be the smallest angle. Well, beta is the smallest angle, so B should be the smallest side. Okay, now let's find B. Okay, so to find B, we're going to focus on this side, the given, and the given.
You go.
So it would be
So what trig function would we use this time? Tangent. We're trying to find opposite. We know adjacent. That's tangent. So put your trig function, leave room for the angle, and then the fraction. What's the angle again?
20.
It's 20.
And it's opposite over adjacent. So it would be B over 6.
So B over
And
6.
then times it by 6.
And this is the one when you want to times by 6. So 6 tan 20 equals B. All right. So take that in and see what we get. 6 tan 20. So 2 point, if we round that to 3 decimal places, what would it be?
2.184.
2.184. Yes, good. Okay, now if I had time and I wanted to double check it, I would try a squared plus b squared and see if it equals c squared, or pretty close. Okay, any question on that one? Again, that was a side and an angle to start. Okay. Look at this one. What's different in this one?
They give you two sides.
They give you two sides. Okay. So when they give you two sides, a little bit different how we have to go about solving it. But before we even start trying to solve it, what do we always want to do?
Draw it.
Draw it out. So we're going to put A over here. Means alpha is going to go there. B, beta, and C. All right. So again, any of those three things you can find first. Which one do we want to find first?
C.
Yeah, we could do C. How are we going to get C?
With Pythagorean.
I thought we didn't want to use Pythagorean theorem.
But we have two sides.
But we have two sides, so why does that matter?
Because both of them are given.
Both of them are given, yeah. You can use Pythagorean theorem because you're not filling in anything that you found. You're just filling in what was given. Okay, so what's Pythagorean theorem going to look like with those sides?
Maybe the square root of 13.
Yeah, it's going to be 3 squared, 2 squared, equals c squared. I think we did one in the homework.
Yes, we did.
So that's 9 and 4. And then we're going to take the square root, and we are going to round it. Okay, so when you have the directions on the test, it is not going to say exact answer. In the homework, it did. It said exact. Okay, but this one, we are going to round. So square root of 13, 3.606. Okay. Any questions on how we got C?
Wait. Oh, never mind.
Okay.
Unless it says exact, then you get rid of square root.
Yeah, and I'll say on the test, like round to 2 decimal places. So yeah, when it says exact, you need to leave the square root. If it says round, then you round it. Okay, alpha or beta? Which
Alpha.
one next? Alpha. Okay, so this was to find C. This is going to be to find alpha. Okay, circle everything we're going to use. This, and that. To figure out the trig function, we need to know what positions we've got. We're never using C, so we don't have to worry about even labeling it. It's not a number we're going to use. What about the side that's 3 units? What position is that?
Adjacent.
Well, everything's from, we're finding alpha, so pretend like you're standing at alpha.
Adjacent.
Opposite.
It's opposite. Adjacent means it's next to it. This side, right here, is not next to alpha. Okay, so that's opposite. The 2 is adjacent. What trig function is that?
Tangent.
Tangent. Okay. How am I going to write down what goes in that equation?
Leave
The adjacent and opposite.
the degrees blank.
Well, we got to put something there. We can't leave it blank.
Put the alpha.
Put the alpha, yeah. And what about on the other side?
Do
3 over 2. That equation is different than any of the other ones we've done. What's different about it?
There's no degree.
Okay, yeah, the angle wasn't given. So this time, the variable is not in the top or the bottom of the fraction. It's in the argument to the trig function. We need to get this by itself. What's preventing it from being by itself? Tan. How are we going to get rid of tan? Remember, tan is a function. You have to get rid of a function with another function. No arithmetic can get rid of a function. So to get rid of the tangent function, we're going to take the inverse tangent function of what's on the left and take the inverse tangent of what's on the right. That's the big difference. Okay? Any problem that you're given two sides to start with, you are going to be solving for an angle. The only way to do it is with inverse trig. What's going to happen when we take inverse tangent of the tangent?
Will it cancel?
These cancel. Technically, it only cancels if this number is between negative 90 and 90. Okay, we learned that yesterday. So if we're between negative 90 and 90, it will cancel. How do I know that this is between negative 90 and 90?
But in 3.
Well, I mean, I haven't solved it yet. So how? But I can tell you that I can cancel these. How do I know that that will be between negative 90 and 90?
Because it's equal to 3/2.
Is it because it's a right triangle and the two angles other than 90 add up to 90? So
Right.
it can't be 90?
Right. I know that this can't be bigger than 90 because it's an acute angle in a right triangle. Right? It has to be smaller than 90, and I know it's going to be more than 0. So if I know it's more than 0 and smaller than 90, is that between negative 90 and 90? Yes. So this formula will work. Right?
Is there ever a case where it won't work?
Not in a right triangle, no. Nope. It always has to work. Non-right triangles, that'll be in a couple weeks. All right, so now you've got alpha by itself. And now you just have to type in inverse tangent of root 3/2. So second inverse tangent, I'm sorry, 3/2. It's 56 point, if we round up, that's 56.31. Okay, so now if I was taking some kind of like time test and I had to finish it really quick, I would just subtract 56.31 from 90 and hope I got 56.31 right. Okay. But as long as I have the time, I'm going to find beta the same way I found alpha. I'm not going to use alpha and I'm not going to use C. So if I make a mistake, it'll only be on that one part. Let's find beta.
What was the answer again?
56.31.
Thank you.
Yep. So now, I'm going to circle everything that we're going to be using. We're finding beta. We're using the 3. And we're using the 2. I'm going to move all that off the screen. Or not. I'll just... So look at what's circled in black. Okay, focus on the black circles. What have we done now with what we're trying to find? We've done something in this triangle.
We found another angle.
We're finding a different angle. What does that mean now? We're trying to solve for a different angle.
Opposite and adjacent switch?
The opposite and adjacent are no longer what they were before. If you switch your angle, which we are doing, we're switching the angle we're trying to find, we need to rename the sides. Okay? That is not something you do in the other type of problem, because you use the given angle to do everything.
So would the adjacent angle now be A?
So adjacent would be which number? 2 or 3? 3.
And then 2 would be opposite.
Yes.
Hager.
Hypotenuse would never switch if you were using it. Okay? But in this problem, we're not.
I didn't hear exactly what you said. Why wouldn't you just subtract 90 plus 56.31 from 90?
Because the 56.31 isn't a given, so it might not be right.
Oh, in case we did it wrong.
Yeah. Yep. So in theory, when we do this, we should have, let's see, it should be 90 minus 56.31. So keep that number in mind. Whatever we're doing now should come out to 33.69. If it does, then I definitely know we did it right. Okay, but just keep that number in mind, 33.69. Okay, so we relabeled our sides because our reference point in the triangle switched. Which trig function are we using now? It's the same one. We're still using opposite and adjacent. They just switch places. So tangent of my angle equals, what's opposite now?
2.
And adjacent?
3.
3. So it's really the same problem, except the fraction just flipped.
So would you do the inverse of tangent?
Yep. Inverse tangent of 2/3. So type in 2/3, and we already know that it should come out to 33.69. Perfect. 33.69. So we get the same answer 2 different ways. But using the inverse trig is better because if you make a mistake, then it will not affect anything else.
Can you go down for 1 second?
So here's finding beta, alpha, and c. Any question on that one? Okay, so that's 2 sides. Anytime that you have this type, you always need inverse trig. 2-side problems are the only ones you use inverse trig. All right. Let's do this one. All right, so we're going to be given this information. Okay, it's all more of a kind of written out. And what do you think the first thing we would want to do after we read through this whole problem would be? Okay, write maybe underline or write down what you know, and then draw it, right? Always draw it. Every problem in this section, you draw it out. Okay, so it says that we're leaning a 20-foot ladder against a house. The angle between the ladder and the house is 17 degrees. How high will the ladder reach? Okay, well, it's a 20-foot ladder. Why wouldn't it just reach 20 feet?
It's smaller.
Because what?
It's going to be smaller or taller.
Why? Because it's slanted, right? It's not like the ladder is like bolted to the side of the house and it's vertical and it's going straight up. The ladder is on an angle. Okay, so let's draw it. What are some important things that we need to put in the diagram of our drawing?
The ladder being 20.
Okay, we need the ladder.
That's a big one.
What else is going to be important in the diagram?
17 degrees.
17 degrees.
Okay, so we're going to label some things with numbers after. I'm just thinking of objects for now.
The house and the ladder.
House, ladder, something else.
Angle. The ground.
We need the ground, yeah. We got to have something that everything is on. So there's our ground. Okay. Here's our house over here. And we've got a ladder leaning against it. Like that. It's not to scale. Okay, what do we know that we can label in that picture?
The ladder.
Ladder is 20 feet.
The ladder is 20 feet. Okay, so that's the length of the ladder from there to there. Okay? What
And then we
else?
have 17 degrees.
Okay, where's that going to go?
Probably.
The top one?
Up here?
Yeah. No.
No.
No. In our right triangle.
Oh, the right triangle.
Oh, yes.
It's the angle between the ladder and the house. If they said the angle between the ladder and the ground, then we'd be talking about the angle that's over here. Okay. So we already realized, somebody just said, we have a right triangle. So here is your triangle. And what is it that you're trying to find in that triangle? I don't have an A there, so I don't know which one you mean.
How high is it?
How high it is. Yeah, the height of the triangle. That's what you want to figure out. And if you want to call it A, that's fine. So are we going to use inverse trig? No? Why?
It's a side angle.
Because it's a side at an angle. Inverse trig is only used if you have to figure out what? The angle. We are not figuring out an angle in this problem. Even if I wanted to, I could figure out this other angle, but all I have to do is subtract 17 from 90. Okay? All right, so let's see if we can figure out what our equation is going to be. Anybody know what trig function we need to use?
Adjacent over opposite.
So we're using this, this, and that. What side is the 20? Hypotenuse. Then you definitely need to use hypotenuse because it was given. So that would eliminate 10.
Oh, so it'd be adjacent over hypotenuse.
So this side is right next to the 17.
So the cosine.
So it would be cosine. What's my angle?
17.
17. Remember, 20 is the length of the ladder.
So
And what's the adjacent over the hypotenuse?
8 over 20.
A over 20. Okay. How do we get A by itself?
Times 20, times by 20.
Times by 20. So times 20 times 20. And that is how high the ladder is going to reach. An angle of 20 is not very much that it's really going to affect how high the ladder reaches significantly. Right. It's still probably going to reach 18 or 19 feet up. So 20 cosine 17. So the ladder will still reach about 19.13 feet. Okay, it wouldn't be till you get this angle all the way to a 60 that the ladder would only reach half as high as it is. And the only way you'd be able to put that all the way at a 60 is maybe if there was like a block or something, you know, fixed into the ground. Then you could put the ladder that steep because it wouldn't slide. But yeah, you'd have to make this angle really, really, really big before the ladder would reach as high. So it still reaches pretty high. All right. Any questions on? No. All right. So let me put up a review of the different topics on the test. Okay, so you definitely want to know how to do inverse trig using both the table, which the table will be on the test. You don't have to print it.
I'm getting the water.
Okay. So, using the table or using the calculator. Let's see, so that pretty much covers 3.1. You should know the formulas when the inverse trig and the regular trig cancel out. So those are the formulas, we'll just call them 2a, 2b, 4a, 4b, 6a, and 6b. So they look something like this. Sine, inverse sine of x equals x. Okay, and we had 5 other ones that look like that. Okay, so we did those yesterday. What else? So 4.1, that's where you should know the 6 trig functions. So if I give you a problem and ask you to find the 6 trig functions, sine, cosine, tangent, secant, cosecant, cosecant. And the last one is solve triangles. Okay, that's where you find all the sides and all the angles.
Do you want that?
Uh,
Sound like a bump.
Yeah.
Yeah, right there. Okay. So you guys get a little bit of time to start the homework. About 20 minutes. If you have any questions or want to ask me anything about the topics on the test, you've got time to do that as well. So we'll have our tests tomorrow, and then we'll have time to finish on Friday if you need it.
Do you want to check my homework?
Yes.